All right, digital operative, welcome. Whether you're a seasoned pro or this is your first mission, you are about to tackle a really core skill. We're going to forget about regular math for a bit. Today, your mission, should you choose to accept it, is to learn how computers multiply using only zeros and ones. We're talking binary multiplication.
So let's set the scene. Imagine you're in a huge, bustling tech market, and you've got a crate full of identical memory cards. Your job is to figure out the total storage. Now, you wouldn't add them up one by one, right? No way, that's way too slow. You'd multiply. Well, computers think the exact same way. They need multiplication to handle massive, repetitive tasks at incredible speeds. And they do it all with just two digits, 0 and 1.
So your objective today is crystal clear. This isn't just some abstract math problem. This is the key that unlocks how computers process, well, everything, from a simple mouse click to the most complex graphics in a video game. So let's get started.
First things first, we've got to cover the rules of engagement. Every mission has them, but you'll be pretty happy to hear that for binary multiplication, there are only 4. And, trust me, they're way simpler than you think.
Okay, let's just blast through these rules. Rule number 1, 0 times 0 is, you guessed it, 0. Easy enough. Next up, 0 times 1 is also 0. No surprises there.
How about 1 times 0? Still 0. Seeing a pattern here?
And finally, the last rule. 1 times 1 is 1. And that's it. Seriously, that is all the multiplication you will ever need to know for this. The real secret isn't in the multiplying, it's in what comes next.
So you're probably wondering, where's the catch? This seems too easy. Well, you're right. The multiplication is easy. The real challenge, the tricky part of this whole mission, is what happens right after, adding the results together. This is where you have to remember your training in base 2 addition, and more specifically, how to handle that carryover when a column adds up to more than 1.
All right, operative. Enough theory. It's time for your first simulation. Let's call it Challenge 1, Calculating Data Bundles. Let's see those new skills in action.
Okay, here's your task. You need to multiply 1, 1 base 2 by 1, 0 base 2. Just a simple 2 by 2 operation to get us started. Let's break down how we're going to do it. Now, this whole method is going to look really familiar. It's basically the exact same long multiplication you learned back in school, just with way simpler rules. So we'll multiply the top number by the digit on the far right of the bottom number, then we do it again with the next digit to the left, but we shift our result over one space, and finally we just add it all up using our binary rules.
Okay, let's do this. Looking at the table, first we multiply the top number 1, 1 by that 0 on the right. Anything times 0 is 0, so our first line is just 0, 0. Next, we multiply 1, 1 by the left digit, which is 1. That gives us 1, 1. But remember the rule. We have to shift this result one place to the left. Okay, now for the addition. Far right column, that's a 0. Middle column, 0 plus 1 is 1. And in the far left column, we just bring down that 1. And there it is, our final answer, 110 base 2. Challenge 1 complete.
Nice work, but that was just the warm-up. Now it's time for the final test. This is the one that involves the carry. For this challenge, think of it as calculating maximum power output. Let's see if you've really got this down. So here's your target. Multiply 1, 1 base 2 by itself. Now this problem is specifically designed to test one thing, how you handle that carry rule during the final addition step. This is the whole shebang right here. Okay, let's walk through the table. First, we multiply 1, 1 by the 1 on the right. That gives us our first line, 1, 1. Then we do it again with the 1 on the left, which gives us 1, 1 again, but shifted one space over. Now for the crucial part, the addition. In the rightmost column, we just bring down the 1. But look at the middle column. We have 1 plus 1. In binary, 1 plus 1 is 1, 0. So we write down the 0, and we carry the 1 over to the next column. In that final column, we now have our carried 1 plus the other 1, which is 1, 0 again, and we just write that down. So our final result is 1, 0, 0, 1.
Let's just quickly recap that addition step, because it's so important. The whole trick was in that middle column. 1 plus 1 gave us 1, 0, which forced us to write down the 0 and carry the 1. That single carry operation, that is the most critical part of this entire process.
And because you correctly handled that carry, you found the final answer, 10001 base 2. Mission success, operative. You have officially passed the evaluation. All right, let's debrief.
You finish the mission, now it's time to make sure we lock in the key intelligence. You know, when you strip away all the details, this whole thing that looks kind of complex, it really just boils down to 2 fundamental steps. That's it. Only 2.
Step 1, you do that incredibly simple 4-rule multiplication. Step 2, you do the base 2 addition, and you just have to correctly handle the carryover. That's the entire secret to binary multiplication. You multiply, then you add correctly.
And this is why your mission today was so critical. This simple 2-step process you just mastered, it's happening billions of times per second inside the CPU, the brain of every computer, every phone, every smart device you own. It is the foundation for absolutely everything, from sending a text to exploring a virtual world.
So I'll leave you with this one last thought. You just multiplied 2 binary digits together, by hand. A modern computer does the exact same thing, but it does it with 64 digits at a time, billions of times a second. You now understand the fundamental principle behind it all. The only difference is the unbelievable speed and scale. Mission accomplished.